Hey everybody, we're going to take a look here at the Titan 9R. That's the modified Titan 9M. We simplify it to make it a little more router friendly here. It's going to be a quick video, so that way you can just pause on any of these operations and take a quick look at the tabs to make the adjustments and keep moving on. So with that, first thing is to do a setup on this part. So we're looking to set this datum up on our top surface of the stock, front edge in the left side corner. And to do that, what we're going to do is I'm actually going to have you go back to the model really quick and go to the origin and go ahead and turn on the x-axis or the visibility of that and the y-axis. The reason we don't need to do the z-axis is because if we have to set the z at all, we have lots of edges that go up and down to help set z, but we don't have any edges that are x or y. So if we turn those on first, it's going to make setup a lot easier if you got to change your datum. And what that means is change like how the x, y, z is in this space orientation. We set x, y, and z for the CNC machines that we run. Jumping back over to CAM, go into the setup. And of course our, select Z and X or Z and Y, it's up to you. And if you need to change your Z, you pick up and down edges. If you got to change it to X, you change, use the side to side axis, or Y, the front to back axis. And once you pick those axes, if your arrows are just not pointing the right direction, that's when you check the boxes for flip to get them going the right way. It should look like this when you're all set up correctly. And we're on stock box point. Going into the stock tab, we want 8, 4, and 0.75 for our distances, and that should make this good to go. Click OK. Click off. First operation, adaptive. Here's our tool, feeds and speeds. Selecting the bottom edge of our part, and we're going to select the inside edge of the circle. We're just going to do adaptive on the main part. We'll worry about this hole a little bit later. Going to put the tool center on boundary. Here are the offsets or heights. Here are the passes information. Big thing, I'm pretty sure I changed this one. And order by area, keeps the tool on one side first, and then it jumps over and does the other side. And we're going to leave a little bit of stock so we can come back and do some finishing passes that are a little bit lighter and should give a smoother finish when done. And then linking, take a look over these, see if anything needs to be changed there. Takes a little bit for the tool generation. Adaptive's kind of a little bit bigger processing power operation, but eventually it all shows up, and it should look like that. And go to horizontal. We're gonna, after the adaptive kind of cleared out the main areas, we're gonna come back with a finishing pass right away and smooth out the top of this part down to that flat surface on each side. Here's our tool. Here's our feeds and speeds. Machining boundary, just the silhouette of the part. Tool can go outside the boundary this time. Our heights. Our passes. Notice no stock to leave this time, which I think is off by default. And any of the linking settings that we need to change here. Right here though, make sure that this is unchecked. Uncheck that thing. Click OK. And you should see some tool paths that finish off both flat areas of the part. Now we're going to work on this center hole. We're going to do it in 2 steps. We're going to do a 2D pocket to clear the top half of the part. Use the 2D pocket to clear the top half of the hole. Same tool, feeds and speeds. Pocket selection is just the bottom edge of that cylindrical surface. Heights, passes. We're going to want to change our maximum step over to 0.1. That's kind of like optimal load and adaptive. It's showing or telling how much of the tool we want to use out of that 1/4 inch. We're going to use 0.1 of it just to keep the workload down. A little bit lighter chips move faster that way. Then we're going to use multiple depths and set that to 1/4 inch. The diameter of our tool is just generally a good rule of thumb for how far we want to step down each time. And anything here that needs to be adjusted, I don't recall anything actually changing. Click OK. That clears out the top half of the hole. Next, we're going to do the bottom half of that hole. So 2D pocket, bottom half. Same tool. Feeds and speeds. The selection is the bottom edge of the hole. Now our heights tab here, the one little difference, we are actually going to change our top height. Instead of top of part, this is rare we change this, but in this case we're going to. We're going to make a selection, and I want you to select this surface, or this top edge, because we already cleared out this much of the hole. So we can have our tool drop in close to this edge to start doing the work. So the top of our area we're working on is that edge. And then the feed height you'll see is set to top height with a 0.2 offset. And that's when the tool will start doing the work. Bottom is a negative 0.1. We're going to have it go down through the bottom a little bit. That way it cleans out that bottom edge nicely. For passes, we're going to set our step over to 0.1. Roughing step down to 0.25. And anything that may need to be changed here, but I don't recall changing any of this. Click OK. And you can see how that helix, the red coil, doesn't start way up here at the top of the part anymore. Now it drops down inside of there, so it'll feed at a faster rate down close to where the work needs to be done, then helix down into the depth it needs to and do the work. Now, as long as this step is first, that's okay, but if we were accidentally doing the bottom half first, that could be a problem because we're going to be plunging the bit into material. So it's really important you do this top half first, bottom half second. Then we're going to do some drilling. Same tool, feeds and speeds. Geometry. Pick our 4 cylindrical surfaces that go all the way through. If you pick one of them and check the box, it might auto-select the other 4 for you. Our heights tab. Change there is the bottom offset. And cycle is just going to be a simple drilling wrap it out. Then we'll clean up the top half of the holes with a boring operation, which is under 2D milling, by the way. 2D milling, bore. Same tool, feeds and speeds. Selections, the cylindrical faces of that counterbore area. Again, if you pick one of them, check the box. It should pick the rest of them for you automatically. Our heights, passes, and linking. Click OK. And then the last operation we're going to do with the flat end mill is a 2D contour, so we can get this part nearly cut out of the stock material. So double click that. Same tool, feeds and speeds. Notice our feed rate is much slower because we're cutting the whole width of the tool, so we just can't move as fast. The selection is the bottom edge of the part. We are going to add tabs, which are these triangle shapes, and that's what connects the part to the outside stock materials. So this just doesn't fall away and wobble and break loose. Do triangle shapes. Here's the sizes for those and by a distance. Our heights, like so. And when you start changing some of these, like this one number, you'll probably see the triangles move down a little bit. That's perfectly okay. That's why I made them a little bit extra tall. Passes. Feed rate. There's multiple depths. I want to change that. And linking. Big one right here is lead out. We want to uncheck that. Otherwise our tool will move away from the object before it lifts up, and that would be bad because we're just cutting a slot. So when it's all done cutting, we want it to just stop and lift straight up. So we uncheck lead out. And then of course ramp, because we want to enter the material nice and easy on the tool and not just plunge into it. And you get those tool paths. Red is the ramping, blue is the tool path, and obviously you can see kind of that triangle shape showing up on the side. You have to do a little bit of cutout when you're done, but it's pretty easy. Then right here, I made a little manual comment, which is right there. You can grab that, click on that operation, and just type in the comment tool change. And that's to remind you that these operations will all be post-processed together to create one file because they're all the same tool. And these two all highlight and get post-processed to create a second job file to do this part. So that manual note is just in there, so a little reminder to post-process each group separately. So then moving on, our parallel. So we're going to switch over to the ball end mill and work on curved surfaces now. Ball end mill. So there's a tool, our feeds and speeds. Selection. Selection is a little bit tricky. Let me show that. I'm going to clear mine. I'm going to pick on that top edge, and then you got to click on the green profile. And then what you have to do is just zoom in, and right now it wants to go all the way around the part, but I just kind of imagine myself driving the car and going down and say, oh, I got to turn here, so click on that edge. And right now the computer doesn't know if we're going to go left or right again, so I click on the next edge. Sure enough, it loops it all the way around for me. And if it's not going the way I want, you click on the next edge to continue the way you want to go. So for example, down here it's not right yet because it goes past, so I click on the second edge there. And I tell it to go back up this way, so I had to click and click just to get that thing turned around. And sure enough, it all looks good. Check mark. That's how you make that selection. And then we're also going to add that inside edge of the hole. We don't need to have the ball end mill go down in there. So that's our selection, tool center on boundary, heights, passes, step over, step down. This essentially sets how far over the tool moves each time. And anything that we need to change here on the linking tab. And then you're going to get a bunch of passes. And the tighter the passes are together, the smoother your part's going to turn out. The further the passes are apart, the little bit more wave-like the surface will be, so a little bit rougher. And really it just comes down to time. More passes, better finish, more time. More space between passes, rougher finish, less time. And then our last one, the scallop command, which by the way, the last two, parallel and scallop, are all over here on that panel. Same tool, feeds and speeds. Selection, just the top edges of these curved pockets. So that top edge and this top edge. Heights, passes. Right there, I'm pretty sure that's what you'll have to set on this one. And linking. And click OK. And if all of those are generating toolpaths as you're going, now's a really good time to do a simulation to see if you have any errors. And remember, when you do a simulation, you can just skip to the end. If you've been watching this a few times already, you can just skip to the end right away. It'll process for a minute or two, but then you can see if you have any red marks. Nope, looks good. At some point or other, you should watch the whole thing start to finish. I was just saying skip to the end if you have been watching each simulation as we are going through this video. And then, like I said, you would highlight the operations that need to be post-processed together, save them as a file. Then when you're ready to do a setup sheet, make sure you click on the setup so you can see that in the window. I want to see the whole thing with the datum showing. And we click setup sheet. And just open. And you're going to get this like little PDF document. Bring that over. And right there you actually get a nice little picture as well of the stock material with where the datum is. And I can see all kinds of information about how big the stock's supposed to be, how big the part is, what's the maximum feed rates on each tool, and then a breakdown of all the individual operations as well. So a very handy sheet for me to quickly look over to see if things look good in general, and print that out on the color laser and bring it with you to the CNC router when we are going through setup. And that pretty much wraps up the Titan 9R for our class. Hope that helps. If you have if something's weird or you have any questions, of course, please let me know. Thanks for watching.